This is what it is. You're going to take like A times B. So it'd be like A times B equals X times Y. So you're just like multiplying across the X, if that makes sense. But that's how you set it up. Okay. This next one, notice like you got segments sticking out. So this on the book where we got this from, they do it like in different order. It doesn't matter. So you could think of it as the whole segment times the outside equaling the whole times the outside. Or I do parts sticking out, I don't know, just go with it, times the whole thing. B, that's how I rate it, equals the part sticking out on the other one. So we'll just call that X times the whole thing Y. So it's more just like a pattern for like the formula. And then this one is very similar to this one on top. It's just now you have a tangent, so that one's a little weird, but it's basically the same, like part sticking out. So I'll do A times the whole thing B equals, and then the way I think about this one is the part sticking out X times the whole thing X. So it's X times X. So I just write X squared. That's how the formula is too. But the reason it's squared is because you're still doing like the same like thing to set it up. So we'll do a couple examples. This first one is from ACT, so I figured to throw that one on there. I don't know if you knew this, but biologists often examine organisms under microscopes. Oh my gosh, I didn't know that. Okay, the circle represents the field of view under a microscope with a diameter of 2 millimeters. Determine the length of the organism if it is located 0.25 millimeters from the bottom of the field of view, round to the nearest hundredth. Okay, so you could actually do this two different ways. One way we learned in the first unit, like the first day of the unit, but I'm going to solve it the way using this theorem, okay? Because it technically is like an X in there. Like maybe tilt your head. Maybe it's a way to think about it. But like this is what I'm going to do. I'm going to go, I need the length of the organism, so I'm going to put X by the squiggly guy. And because it looks like we're drawing the diameter here, okay, because this is a diameter, that means that this is also X, okay? That's like one of the theorems from the first day of the unit. So because that's a diameter and we've got a chord, those we can assume are the same. Then what I'm going to do is I'm going to go like X times X, following the formula, equals, and then I'm going to do like this little chunk times this big chunk. So I'm going to go 0.25 times, and then that longer chunk, it doesn't even say. Oh, wait, they give you the diameter's 2 millimeters, right? So if the diameter is 2 millimeters, what is that, 1.75 for that? So you would solve that one. So you would get, what, X squared equals, oh, I don't know what that is, 7/16. I don't know what that is. It's a decimal, and then you square root it. So whatever that is the square root. I think I remember this. I think it was 0.66. I think. Can someone check? Go 0.25 times 1.75, and then square root it. And then what's the square root of it? As a decimal. It is? Okay, yes. I remember. Woo. Okay. Because they said round hundredths, so then millimeters. So 0.66. So that one's kind of like the weirdest one with an application to it. Okay. And then I'll do full on these next four because it's more of like the algebra with this. So like number 2, notice that you've got like the segments are sticking out of the circle. So you're going to be using this middle one. So you're going to take the chunk sticking out times the whole thing equals chunk sticking out times the whole thing. Okay, so I'm going to start, I don't know, let's just start with this guy, x. So I'm going to go x times this whole thing. So if you're going to do that whole thing, you got to add them up. So this is like more hardcore because it's going to be x plus 24. So just make sure for like your own sanity, just write it as parentheses because then you'll remember when to like distribute and stuff with all of these. And then this next one would be 25 times this whole thing. Usually I just add them right away, but you don't have to. So I usually just add them, get 52, and then multiply it out. Okay, so sometimes they give you the whole length too, so that's hopefully not as bad. So now you're just going to distribute, and you might notice already that it's going to be a hard one because, and then this I think was 1300 from what I remember. And we've got a quadratic. Yay! Loving life. So I'm going to scooch that 1300 over. And I'm like, am I really going to factor this? Because I'm going to start crying. Well, so it actually is factorable, so I'll help you with that. If it's not, quadratic formula. I wrote on the board if you forgot it. But it's a nice little song. I could play it later if you want. But if, like this one, 1300, I'm usually like, no. Like personally, I would have done 13 and 100, because that's like the first thing that came to my head. And then the 13 and 100, the difference of those is not 24, so denied. So then I tried 26 and 50. So if you divide 100 by 2 and put that 2 with the 13, 26 and 50 actually works. Believe it or not. So if you do x and x, 26 and 50, those two multiply to 1300. Okay, but then their difference is 24. But wait, I need a positive 24. So that goes with the 50, right? Yeah. So if you don't want to factor it, throw it in quadratic, which is a little painful, but it works every time. So then now you're going to set each equal to 0. So you get 26, and then you get a little weary with the negative guy. And usually the negative doesn't work in these ones because the x is usually like an actual length on the picture. So the negative 50 is out. So it's just 26. So we got some factoring going. So just kind of keep that in mind as you're suffering through everything. This next one, this is the last one, like that tangent one. So what I'm going to do for setup is you're going to go 20 times the whole thing. So what is that, 45 if you add them? So 20 times 45 equals, and this is the one where it's kind of weird. You're going to go x, the part sticking out times the whole thing, which is x. So I usually just square it right away. And again, it's the last formula on the bottom. So then this is 900, so 30 for your answer. Okay. All right, next page. Number 3 looks terrifying, but honestly, it's only the first step that's horrible. Okay, so like the first step in solving is not fun, but then after that, everything, there's like a lot of stuff that cancels, which is really nice. So this one is like the x one, so you're going to use the top one for the formula. So it doesn't matter which x you start with or like which line. I'm just going to I'm going to do this one just because this is my feeling this vibe here. So I'm going to go x times x plus 10 equals, and then this one, so this is what I'm saying, make sure you put parentheses for your sanity. Because you want to make sure that you're not doing any like illegal stuff. And then it helps you like, now it looks more like distributing. Do you know what I mean? Just looks better right away. So now you're just going to kind of suffer. You're just going to distribute forever. Okay? So you go x times x, x squared, and then you might have a panic attack because of the squaring stuff, but it'll be okay. Plus 10x. And then the blue part, you got to do like all the distributing stuff, you know, like you go x times x, x squared, x times 2, 2x, 4 times x, 4x, 4 times 2, 8. And then what's great about it is your squareds are gone. So it actually is really just the first step. Don't mess up, and then you should be fine. Because now it's just, what does it simplify to? 6x plus 8. That's cute. Now it's cute, you know? So you get 8, and now you get 2. So, yeah, just distribute right. That's what people mess up on that one. Okay, so this one, make sure you do distribute property. Oh, number 4, people get the setup wrong. Okay, so here's another, like, the tangent one where you're going to have to square it. So here's the deal. People don't have issues with the x part. They'll do x times. Now this is the crazy one. You have to do the whole length, okay? The whole thing. So the whole thing is the red x, right? Plus the x plus 2. Do you know what I'm saying? So it's like, scary. You know what I mean? But that's how you get that whole thing. So you're going to take the red x plus this x plus 2. So it's 2 x's, right? So it would be 2x plus 2 for the whole, like, whole thing, right? And then this equals 12 times 12. So I'll just write 12 squared because that's easier for me to do. And then this is where you might be like, oh no, 2x squared plus 2x equals 144. No. It's a quadratic. But 2's. Do you see the 2's? Get all the 2's out. Yeah, exactly. Because factoring with a leading is annoying. Okay? So clean up the 2's. So divide out all the 2's from everything. So we're going to scale it down. What is that? 72, right? Yeah. It's okay. So then I'm going to move over the 72. Okay, please be factorable. Please be factorable. If it's not, you're doing quadratic. Yeah. It is 8, 9. Look at there. But I need positive 9 because I want positive x. So then that would be what? X equals 8 and x equals negative 9. Can I do the negative? Nope. So just 8 for your answer. Okay. So what I'd like you guys to do is just set up the rest. Don't solve them. Just set them up. Okay? Set them up as fast as you can. Don't solve. Okay?